Why hello there, I am Shanice Potato, and welcome to my YouTube channel. Now you may be wondering, what exactly is going on right now? And to that, I have an answer for you. Now you're probably slightly confused as to why this video is called Part 1 to Erton Theory and not Episode 3 to my initial theory. Well, you see, Episode 3 of my initial theory was supposed to be about me constructing a larger scale ion thruster to fully test it, which I simply don't have the materials to do at the moment. So instead of continuing with that, which I will eventually in the future, I'd like to share another theory that I have with all of you. Today, I'm going to be talking about relativity and the function of the space-time continuum. Objectively, one of Einstein's most famous works is his theory of relativity, and also his theory on the space-time continuum. Now, the space-time continuum, or the space-time fabric, is essentially this fourth-dimensional plane that bends and warps around masses proportional to their gravity. Now, up here are a couple of things. Here I have a base diagram of space-time warping around a mass and how it does that, along with a smaller mass accelerating into it. This is a diagram of how a wormhole would function. Of course, wormholes are still only theoretical and haven't been directly proven, but if they are real, this is what they would look like, and this is essentially what it is, just a hole in the space-time fabric between two sides of it. Now up here are a couple of relevant equations, such as this equation representing gravitational time dilation. This equation also for time dilation except with respect to velocity instead. This equation representing the Lorentz law, which is 1 over the square root of 1 minus velocity squared divided by the speed of light squared. This is Newton's law of gravitation, or the force between two objects of attraction is equal to the gravitational constant times mass 1 times mass 2 divided by the distance between them squared. And this equation here is Einstein's law for the curvature of space-time. But despite all the funny numbers mentioned up here, I have yet to mention what Erton theory actually is, and that's what I'm going to get into. Now, my theory, Erton theory, essentially states that the space-time continuum itself is made up of tiny, massless, formless particles, which I call ertons, and their charge determines whether space-time is curved or not, and the attraction to the mass itself. In other words, the more mass that's present, the more charge that an erton has. The more charge it has, then the lower the space-time continuum is. Or in more simplified terms, stronger erton charge equals stronger gravity, and that's proportional to larger mass. Now, ertons themselves have three different charges that I claim, all depending, of course, on where they are in the space-time continuum when it's moving. If they're at a dormant state, meaning which I call the amber line, which is essentially a state, the natural resting place of the space-time continuum, when there's no mass present on it whatsoever, just empty space. The other form of erton being when it's above the amber line, fourth dimensionally, which is when it's in a positive state, which I call positron, and the other form when it's below the amber line, which would be like when normal mass is, which I call an anerton, or a negative erton. Now, this may all seem relatively simple and not really worth much of a theory at all, but there's a bit more to it than what I just explained. But with all that said, I think it's time to move on to the next part. So after that little demonstration, I then set off in search of my next filming location, which hopefully wouldn't be very far from here. I then got into my handy science-mobile and traveled out into the open road. Amidst my journey, I encountered a rather interesting sight on the side of the road, but this didn't dissuade me from my mission. But unfortunately, after a couple small sips of my chloroform flask, I appeared to no longer be in the proper condition to drive. Now, you may have heard me mention earlier the fourth dimension, but some of you might be confused as what actually is the fourth dimension. And to that I have an answer for you. Now, most people are familiar with the three dimensions, length, width, and height, but there's actually a fourth dimension, and the general consensus to what the fourth dimension is the fourth dimension is time. Now, the way I've always looked at it is that if time is a dimension, then it's the same thing as length, width, or height, which is kind of the same thing as the universe being this flat plane, everything existing on in this 2D world, and this 3D world that nothing on the 2D world can sort of really comprehend. Now, the way I've looked at it is that if time is a dimension, then the universe, this flat plane, must be moving in that one direction forward in time, thus explaining how we experience time here in the universe, even though it's a dimension out of our comprehension. Now, how gravity works is that stuff on that plane bend it, and they create a curve, and that's how stuff sort of spins down and orbits around it. Makes sense. This also infers how things like gravitational time dilation work, because if the universe is moving forward and there's a dent, and you go into it, then you're moving slower in time than everything else around you, which is just what time dilation is. But there's a problem with that. You see, the universe space-time continuum isn't a flat plane. It's all jumbled up like a big crumpled ball of paper. And that makes absolutely no sense, because if this is moving forward at time, then just stepping in any direction, you would be traversing time, and time would be different literally everywhere in the universe from everywhere else, which is obviously not how that works. This is why in relativistic physics, time functions a little less like a dimension and more like a force, kind of like a mix between the two, and it's very convoluted if you really look into it. This is why I have a theory. I believe that time is not the fourth dimension. I believe it's rather the fifth dimension, and this is how I'm going to explain it. Now, this would also explain where you get things like time dilation with moving at velocity. When something moves really fast, its time will slow down. But its mass doesn't change. If its mass did change, that would be completely violating the laws of physics. So I view it as when that mass, whatever it is moving really fast, it bends the fifth dimensional fabric. So as it's moving, it's sort of pushing down on the fifth dimensional fabric, but not the fourth dimensional fabric, allowing it to stay at the same mass, but to move slower in time as it bends fifth dimensionally. Now this is where Erton theory comes in. You may notice that space-time is all squiggled up like this, all these bunch of lines on the paper. So how does Erton theory work? Well, the idea is that all those lines are made up of ertons, and when that mass is present, it pushes on it as the ertons are attracted to the mass, and that's what creates that. And when another mass comes in, those negatively charged ertons will attract it and pull it closer because the charge gets greater as the mass goes in. Pretty simple. This works the same way with positons, which is how you get things like negative gravity, or sort of ertons that repel mass instead of attract it. Positons happen when that line moves sort of above the amber line. The amber line, as I said earlier, is the natural resting place of those ertons, or essentially when no mass is present, then the ertons have no charge. They're completely dormant and neutral, so there's no gravitational effect whatsoever. Now, that does beg another question. If time is the fifth dimension, then what the hell is the fourth dimension? And to that, I kind of have an answer for you. Now, you could look at it as space is the fourth dimension, but that's really not what it is. The fourth dimension is kind of just this empty space, this empty gap between the third dimensional world that just kind of exists. Now, gravity isn't a dimension at all, so you can't assume that gravity is the fourth dimension. Gravity is a force, not an actual movement or direction. But with all that said, I think that gives us all a pretty good understanding what Erton theory actually is. So with that, let's move on to the next part. Now, Erton theory does have some good points to it. It does explain how the space-time continuum moves the way it does. It being made up of particles would explain how it moves in waves and sort of bends around stuff, just like how a piece of fabric would, or how even water would behave. But it does, of course, have some drawbacks. You see, my knowledge in the field is limited. I don't have a PhD or a degree of any kind. There also is the potential it may not even be possible to prove whether this theory is right or not, considering that ertons are so small and at such a scale that they may not be observable whatsoever. Of course, mathematics may be able to prove it. There still is that possibility that there is no way to prove it. Another problem being that we are dealing with particles smaller than the Planck length, and the Planck length is essentially the smallest possible unit that we have, which is where space-time fabric becomes visible. But a problem with that is imagining units smaller than the Planck length can sort of break physics. But this is kind of okay, since ertons are technically massless and formless particles that kind of don't even really exist on the same plane of existence as us, which means they technically exist smaller than the Planck length, but they also kind of don't exist. But despite all of this, I have no idea if any of this is correct. I kind of think it's correct, but at the same time, that's pretty much it. And like and subscribe. Thanks for watching.